are in many ways the workhorse of Python. They are incredibly flexible and useful for a variety of applications. So lists, like strings, are a sequence in Python, but whereas strings are sequences of characters, lists are sequences of any kind of Python object. So lists can be heterogeneous, apples and oranges. That is, that every element in the list does not have to be of the same type. And any Python object can be an element in the list. So I can have numbers, I can have strings, I can have other lists, other collections, I can have functions. Anything that's any valid object in Python can be in a string. So strings are created using square brackets. So here are some examples of generating different strings. So here I have a list of numbers, 1, 2, 3. Here I have numbers and strings. In the third case, I have numbers, strings, and a list. So lists can, in addition to this kind of explicit enumeration of the list items, lists can also be created with the list function. So in this case, I'm taking a list, creating a list from the list function, and I'm passing in a tuple, 1, 2, 3. We'll talk about that. In this case, it's a dictionary. In this case, it's a string. Let's see what the results are in each case. Okay, so the different behavior, so a tuple to a list is pretty straightforward. The dictionary to a list has some explaining to do, because here we have 1, 2, 3, 4 pieces of the list, but we only have 2 things that are returned in the list. And then in this case we have the string, where each element of the string becomes an individual element in the list. So the string Brian becomes the list Brian. Okay, what if we try to do it with a number? Well, then we get an error, because this says int object is not iterable. So this list function is looking for something where there's more than one part to it, and it's going to go from the first to the last part. That's the iteration. Okay, what are some of the utility functions that come with list? Well, perhaps the most common one is the range functions. So this creates a list of elements that are specified by the parameters that are provided to range. So if I do the help function here, it says that I'm providing a stop position. So that is the exclusive last value to be generated. Or we can do it starting from something, stopping at something, and stepping at a particular size. Again, the stop, just as we talked about with strings with slicing, is exclusive. The range function will not create this last value. It will create up to the stop value. So here's some different prints. So here we're generating a range with without a provided start, so that's taken to be 0. So we have 0 up to and including 9. So up to but not including 10. Here we're going from 0 to 10 in steps of 2. And here we're going from 10 to 0 in steps of -1. And again, you see that the stop, which in this case is 0, is not included in the returned range. Okay, is A1 a valid list? Yes, it's simply an empty list. So here we have a list A2, which consists of numbers, strings, and an empty list. So let's see what we have here. Let's insert below. So you see that here we're assigning A2 to B. And I just want to see if I have a comment on this. Let's just explore this. I might have this later. But is B a reference to A2 or is it a copy? So that relates to, now that I've set B equal to A2, if I change A2, does it change B? Or if I change B, does it also change A2? So what if I do B, and then I'm just going to append, we're going to talk about this in a second. I print B. Okay, see, now I've added Brian to the end, but what happened to A2? So let's insert another cell below. Print A2. You see A2 also has Brian at the end. So this B in this case is not a new object. It's simply a synonym for A2. B and A2 are referencing the same object in Python. Okay, just as with strings, we use square brackets to access particular elements of the string. We also use that with lists. And just as whereas string sequences started with 0, lists also are indexed from 0. So we can insert data in a variety of ways. Append, which I used up here, adds an element to the end of the list. Insert, we provide an index of where we want to insert something and what we're going to insert. And extend takes two lists and extends the first list by the second list. And then the concatenation, the plus symbol. If we take two lists and we concatenate them, it returns a new list, which are the two lists glued together. So let's look at what we get here. So I'm starting with an empty list. I'm going to append Brian, and then I'm going to insert at position 0 the number 39. And then I'm going to print that. So let's just do that to that point. Okay, so I ended up with 39 Brian. Okay, now I'm going to insert at position 1 the list 1, 2, 3, 4, 5. And so remember, it starts at 0, so 39 is at 0. The next position is 1. So this should put us a list in between 39 and Brian. Okay. All right, so now this is a demonstration of concatenation. I have two lists. When I concatenate them together, it will create one list that's 6 elements long. 1, 2, 3, 4, 5, 6. Here I'm creating a list B that's 1, 2, 3, and I'm extending it by the list A, comma B. So when I print that, I now have 1, 2, 3, AB. Now that contrasts with appending, where in this case, I'm taking the list that's 1, 2, 3, and I'm appending the list A, B. And so now I have at the last position a single list that has two elements, A and B. I have this here on are there efficiency. You see that extending and concatenating have the same costs associated with them. Okay, let's come down here to accessing data. So we can index either from the left or the right. We index from the left starting at 0. We index at the right starting from -1. So the last element in the list is -1. The second to last element in the list is -2. And so on. And I have to warn you, that can create unexpected problems. If you have arithmetic errors that give you a negative number that you're not expecting, in Python you will not get an error by accessing with a negative index. You will just be accessing from the right instead of from the left. And slicing behaves the same as we demonstrated with strings. So here's just some of the output from that. Okay, lists, as we've already seen that we can append to them, so forth, are mutable. Lists can change. So we can change things either by assignment using a single indexing. We can also do assignment with slicing. We can modify lists in place with sort. We can reverse their order. We can pop off elements out of them, and we can delete elements. And so here's just showing what the pop method does with the list. And here's just some demonstrations of that behavior and some more timing. So again, lists are very valuable, very useful, maybe the most commonly used collection in Python. 2 key points. Lists can be heterogeneous. That is, not every element in the list has to be the same. Lists can contain, I'm going to make it, I said 3 things. Lists can contain any type of Python object, and lists are mutable. They can be changed.